All right. So our first question of today, in today's class, uh, the question says that the roots of equation 2 x squared plus 6x minus 2 is equals to 0 are alpha and beta. Okay. So whenever they talk about roots, you need to understand that roots are only what? Solutions. Okay. So you need to note this. Roots are just solutions. Okay. And these solutions are solutions of x. That is one thing you need to note. So when they say that the roots of this equation are alpha and beta, they mean that the solutions of this quadratic equation, they are alpha and beta. That is one thing you need to note. Now, the first question, it says that find the value of alpha minus beta, then beta minus alpha. Okay, that is what they want us to find the value for. But before we find the value of this expression they've given us, you need to note down to say that, okay, uh, what do they mean when they say alpha and beta, and what are their uses? Okay, so we have the quadratic equation, which is 2x squared plus 6x minus 2 equals to 0. Okay, and they're saying that the roots of this is alpha and beta. Okay, so the first thing we're supposed to do is to find the sum of these roots and the products of these roots. So the sum is equals to alpha plus beta, okay, which is just equals to uh, negative b over a. That is the formula of you finding the sum of the roots of the equation. Okay, like the sum of the roots of the equation. Then now the product, I'll write it here. Product is equals to alpha beta, which is just equals to c over a. That is one thing you need to note. Then now you need to you have been given this quadratic equation, and you know that a in this case is equals, because the quadratic equation is usually like this: ax squared plus bx plus c. So a is the one which has the x squared there. So this tells us our a is equals to 2, our b is equals to 6, and our c is equals to negative 2. Okay, those things have been noted. So when you're finding sum, it is equals to alpha plus beta, which is just equals to negative b over a. Then this implies that this is just equals to what is negative b. So it's negative on the formula, then b is 6, okay, divided by a, which is just a 2. As a result, you're going to have negative 6 over 2. As a result, this will be equals to negative 3. Okay, so that is sorted. Now what about the product? The product, so we've identified that it is c over a. So this tells us that this is just equals to, yes, someone has a question, you are free to ask your question. Okay, so if the silence, meaning that there's no question. Okay, so now here I said c alpha beta is equals to c over a. What is my c? C is negative 2. So I'll write negative 2 divided by a, which is just what? 2. As a result, my product is going to be negative 1. Okay, are we together up to this point? So you're free to unmute yourself and just respond. You have, if you've gotten, so that I can be getting your feedback. Is it clear?
Yes. Yes, sir.
All right. All right.
Yes, sir.
Wonderful. So now our question.
Yes, sir.
Yes. Wonderful. Thank you very much. So I they want us to calculate for alpha minus beta, then beta minus alpha. So the first thing that you do here, because the only thing that you know as a solution, because you only know the sum and the product. Okay, so meaning that you need to arrange in such a way that this expression becomes in form of alpha and beta, or like alpha and like for the sum and the product. That's when you can solve it. So in this case, you have alpha minus beta, beta minus alpha, meaning that you're going to multiply to expand this by saying alpha. Okay, alpha is going to multiply with everything that is here, which is beta minus alpha. Then negative beta is going to multiply with beta minus alpha, like this. Okay, so when that happens, you're going to have alpha beta, which is the product. Then you're going to have minus alpha squared.
Sir, we can't see the screen.
Okay. Okay, so I was saying that the question is asking us to find alpha minus beta, then beta minus alpha, then meaning that I need to expand this. Okay, we know how to expand. So alpha, which is alpha here, is multiplying with everything that is here in the second brackets.
No, some of us cannot.
All right, no problem. I'll re-explain. Okay, so when you're expanding here, we have alpha minus beta. So when you're expanding, don't panic, you just get you get one variable here, alpha, and you multiply with everything
Sorry,
that
sir,
is
I
here.
can't see the screen.
All right, so when you're expanding, I'll just explain. Sorry for assuming that everyone knows. So you get the alpha, like the first one here, you get alpha, then you open the brackets, then you multiply with everything that is here. Okay, so which is beta minus alpha. Then you get the second variable, which is negative b, and you multiply with everything, which is b minus alpha. Okay, so that's how you expand. Then you start multiplying. Clear to those who?
Yes, sir.
All right. Okay, so let's continue what we're solving. So here we said that we expanded, then we started multiplying. Alpha times beta, it was alpha beta. Alpha times negative a, which is negative alpha, which became negative alpha squared. Then negative b times beta, it became negative beta squared. Then negative beta times negative a, it's going to be plus alpha beta. Okay, so now, so now, so just mute yourselves. Okay, don't forget to mute yourselves. Okay, so now you have alpha beta, alpha beta. So this is going to be you correct the right terms. This one is positive, so so they're going to add. So it's going to be alpha beta and alpha beta, they will become 2 alpha beta. Then you're going to remain with negative alpha squared minus beta squared. Okay, so now here what you're going to realize is that you have this. Okay, alpha beta, so meaning that this one can be solved for alpha beta, but you can't solve these ones. Okay, so we need to find a way we can express these ones. Okay, we need to express to replace them with variables that are going to be equal to the same thing, but they will be in a form where there is sum and product. Okay, so now what I did when I was solving this question, I did this. I have 2 alpha beta, then I have, it will be this one. What is common here? If I was to ask what is common here between the two?
Negative.
Okay, negative, right? So we'll say negative 1. So I'll say what is common is negative 1. Then I'm going to have alpha squared plus, because this is negative 1 into this is alpha squared. Negative 1 into, this one is beta squared, yes. So negative 1 into beta squared is going to be beta squared, like this. Okay, so now How can I get alpha squared plus beta squared? You're going to realize that you can get this in an equation by saying alpha plus beta squared. You're expanding this one, right? When you're expanding this one, you get to say you are going to have alpha plus beta, and then you're also going to have alpha plus beta, alpha plus beta. Then you're going to multiply. You're going to have alpha squared is like this one. You're going to have alpha plus beta squared is equals to alpha squared plus uh, alpha beta plus alpha beta plus beta squared. As a result, you're going to have alpha plus beta squared is equals to alpha squared, and then I'll get the beta squared because that's my interest, plus beta squared. Then these two are going to add, I'm going to have plus 2 alpha beta. So now when I have this, I'm going to take this, I'll make alpha squared plus beta squared to be subject to a formula, meaning that I'm going to have alpha plus beta, which is squared, and then I'll say minus 2 alpha beta. Okay, because this one has come this side, is equals to alpha squared plus beta squared. Okay, so after I've done this, I have solved this one. So meaning that where there is alpha squared plus beta squared, I'll replace it with this variable which is here. So I'm going to have 2 alpha beta minus 1. Then everything here I'll replace with this component here, which is alpha plus beta. Oh, let me write it properly. Okay, so it's going to be alpha plus beta squared, then minus 2 alpha beta. Okay, so after I do this, I'm going to have a 2 alpha beta. Negative 1 times this one is going to be negative alpha plus beta squared, then minus, oh, negative 1 times negative 2 alpha beta is going to be positive. It's going to be positive 2 alpha beta. Okay, so now I have the product, the sum and the product. So 2 alpha beta plus 2 alpha beta, that will be 4 alpha beta. Okay, so that will be 4 alpha beta, then minus alpha plus beta squared. Okay, so now this is easier for you to solve. Okay, so now what you're going to do is you're going to replace here. Remember what we found as our product. Our product was negative 1, which is alpha beta, and then our sum is negative 3. So you're going to come here and just say 4. Then where there is alpha beta, you replace with negative 1. Then where there is alpha plus beta, you replace with what? Negative 3. Okay, squared. Then this is going to give us negative 4. Then this will be minus negative 3 squared, that will be a 9. Okay, positive 9, then it will have the negative there, it becomes negative 9. As a result, negative 4 minus 9 is just equals to negative 13. Okay, clear? Are we clear?
Yes, sir, it's clear.
All right, wonderful. Thank you very much for the feedback. Okay, so now we go to 2. Okay, so that's what you'll be doing. Like, just be practical about it, and practice more. That's the only way you can get to get used to this. So this one, the next question is, they are saying that write down a quadratic equation whose roots are alpha plus 1 over beta and beta plus 1 over alpha. Okay, so those are the two roots which they have given us the new equation which it has. Okay, so I'll go this side. So 2 So the roots are alpha plus 1 over beta and beta plus 1 over alpha. Okay, if I'm not mistaken. Okay, yes, that is the way it is. So now the first thing that I'm going to assure you is that the first thing you're supposed to do what to calculate for the sum. Okay, sum of these roots. Okay, you need to calculate for the sum of the roots. So you're going to say sum. Okay, the sum of the roots is going to be alpha plus 1 over beta plus beta plus 1 over alpha. Then here you're going to say that the sum is equals to alpha. So you're going to get the common denominator, which is you just multiply these two which are at the bottom. You're going to have alpha beta. Alpha times beta is going to be alpha beta. Then now you're going to multiply this one times this one, then this one times this one. As a result, it is going to be alpha is multiplying with, so it's alpha multiplying with alpha plus 1, then beta, so it's plus beta multiplying with beta plus 1. Okay, like that. So as a result, you're going to have your sum to be equals to alpha squared, okay, alpha squared plus alpha, then plus beta squared plus beta. Okay, that is what you're going to have over alpha beta. Then your sum is going to be equals to alpha squared plus beta squared, then plus alpha plus beta. So this one you can calculate for, okay, but this one you have to do the same thing I did that time, okay, over alpha beta. But since we've already done for alpha plus alpha squared plus beta squared, so we already have it. So alpha squared plus beta squared is equals to this identity. Okay, so we're going to get this and replace it there. Okay, so meaning that my sum is going to be equals to my sum is going to be equals to this one is going to be alpha plus beta squared minus 2 alpha beta. Okay, it will replace everything here of then plus alpha plus beta. Okay, like this. Then you say over alpha beta. Okay, now you can calculate for the sum. Therefore, your sum is going to be equals to what is alpha plus beta? It is negative 3 because you're going to use this. It's just the same question. So you're still going to use the same values you calculated at the start, sum and the product, which is these values, negative 3 and negative 1. So you start replacing here. For the first one, you write negative 3 squared minus 2. Alpha beta is negative 1. Then plus, this is alpha plus beta, meaning that everything there is negative 3. Okay, over alpha beta is negative 1. As a result, this is going to give us our sum will be equals to, okay, so trying to see if I have more space. Okay, so my sum is going to be negative 3 squared, that is just 9. Then I'm going to have a negative 2 times negative 1, that will be plus 2. Then I'm going to have minus 3 over negative 1. And then this is going to be equals to 9 plus 2, that is 11, minus 3, that will be 8 over negative 1. As a result, my sum is equals to negative what? 8. Okay, now let me find my product. My product, I'll just get the same roots they've given me, which is alpha plus 1 over beta. Then I'm multiplying it with beta plus 1 over alpha. As a result, I'm going to have, so these will multiply at the bottom. It's going to be alpha beta. Then on top, I'm going to have alpha multiplying with everything. So I'm going to have alpha multiplying with beta plus 1. Okay, then I'll say plus 1 multiplying with uh, plus 1 multiplying with beta plus 1. Okay, as a result, this is going to be equals to uh, alpha times beta. It's going to be alpha beta. Then alpha times 1, that will be plus alpha. Okay, then positive 1 times beta is going to be plus beta. Then 1 times 1, that will be plus 1 over alpha beta. Then you start replacing. Okay, alpha beta is negative 1. Then plus alpha plus beta, which is just plus negative 3. Okay, then plus the 1 over alpha beta is negative 1. As a result, this is going to give us, so our product is equals to negative 1 plus negative 3, that will be negative 4, plus 1, it will be negative 3. Okay, then over negative 1, meaning that it will be equals to positive 3. Are we together up to this point?
Yes, sir.
Okay, so when you reach this point, you're going to say that your equation, the formula, okay, the formula of the equation that you're going to have is that the formula is that you are supposed to have x squared minus sx plus p, okay, is equals to 0. This is the formula you're supposed to have. Okay, so put it to the back of your mind, this one. Then you're going to say x squared, then minus the sum. What was the sum? The sum we got was negative 8. So you're going to replace it with negative 8. You write the x, then plus the product, which is just 3, is equals to 0. As a result, your equation is going to be x squared plus 8x plus 3 is equals to 0. Clear?
Loud and clear, sir.
All right, thank you. We go to the other question. So the other question is saying that find the value of k so that the graph of the quadratic function f of x is equals to 2k minus 1 x squared minus 4kx plus 4 will meet the x-axis at exactly 1 point. So meaning that the graph of this one is just supposed to touch the x-axis once. Okay, and this graph maybe it's like this, but it's touching the x-axis at 1 point. It tells us that for this function, which only has one solution, the discriminant of this quadratic equation is equals to 0. So there are different things that you need to know about the discriminant, and I'm sure you've learned in your tutorial sheet, you've seen some questions when they're talking about the discriminant. Okay, so there are some effects that the discriminant causes. When I talk about the discriminant, what I just mean is that I mean this: when you have this equation like negative plus or minus the square root of b squared minus 4ac over 2a. This one which is here, it is the discriminant. Okay, so it determines the solutions, because if you get a negative value here on top, it will mean that the solution you're going to get is going to be complex numbers. Okay, if you get a positive value which is greater than 0, meaning that you're going to have two different solutions. Then when you get one solution, for example, you get 0 inside. Okay, when you get 0 inside here, meaning that you're going to have one solution. Okay, you're going to have one solution. So that tells us that this discriminant, it affects the solutions of x. Okay, are we together? So here uh, we have a quadratic equation, and they are saying that we only have one x value. So this is just telling us that the discriminant is equals to what? To 0. Okay, and mind you, discriminant is equals to b squared minus 4ac. So meaning that if you have a function f of x is equals to 2k minus 1, then you have x squared minus 4k x plus 4. So they want us to find the value of k from this quadratic equation. So this is our a. Here we are going to name these. So a here is equals to 2k minus 1 because that is the one with x squared. So that is our a. Then our b, in this case, b is equals to negative 4k. And our c is equals to 4. Okay, so those are the things that we have. So here we have b squared, we have so minus this. So we're supposed to find the value of k. So in this case, we've identified what d is because we have one solution, meaning that it is 0 is equals to what is our b squared? B is negative 4k. So it's going to be negative 4k. Then I'm going to square it. Then I'm going to say minus 4. What is my a? My a is 2k minus 1. Okay, what is my c? My c is 4. Okay, as a result, I'm going to have 0 is equals to negative 4k squared is 16k squared. Negative 4 times 2k is going to be negative 8k. Negative 4 times negative 1. Oh, before I do that, let me not do that. Okay, to avoid mistakes. So it's going to be negative 4. Then 4 is going to multiply with everything that is here, meaning that I'm going to have 8k minus 4. Okay, then now after that, the 4 now let it multiply everything. So it's going to be 0 is equals to 16k squared. And then this is going to be minus 4 times 8, that will be a 32k. Then negative 4 times negative 4, that will be plus 16. So now I have a quadratic equation. Okay, so in this case, I'll try to find my product. What is my product? I'll multiply the one with the squared there, the number, and this. So it's 16 times 16. So 16 times 16, this will be going to be 6, carry 3. 1 times 6, that is 6, plus 3, that will be 96, 0. 1 times 6, that will be a 6. 1 times 1, that will be a 1. As a result, this is 6, this is 5, then this is going to be 2. Okay, so 256. So this is telling us that our product is 256. Then our sum is equals to negative 32. Okay, so what this just tells us that we have to look for two numbers such that when we replace them, two numbers when you replace them and you multiply, like when you multiply them, you get you get you get 256. When you add them, you get negative 32. What are those two numbers? Anyone? What are the factors? Okay, so the two numbers, so you're actually right. Okay, it is negative 16 and negative 16, because when you like if you add negative 16 plus negative 16, it's going to give you negative 32. Then when you multiply negative 16 times negative 16, meaning that you're going to get 256. Okay, are we together? Okay, so meaning that I have my product, I have my sum, I have my factors. Okay, so you can use whichever method you are comfortable with. You can use completing the square. You can use even that method because they've not specified here. Yes?
Sir Gertrude asked, how about dividing by 16 the whole equation?
Or dividing by 69. Okay. Yeah, that actually can also help. Yeah, you can do that as well. You divide by 16 the entire equation. It won't affect, it will still be the same equation. Okay. Uh yeah, you can do that. Yeah, but even this one is 2 weeks. So meaning that here you're going to write 0 is equals to 16k squared. Okay, then you're going to replace the sum, which is negative 3 negative 32k, with the factors, which is going to be minus 16. Then you just add the k. Then you say minus 16, you just add the k. Then you say plus 16. Like that, you've not changed the equation, you've just replaced this one with the factors. Okay, as a result, 0 is going to be equals to, what's common here is 16k. Okay, open bracket, 16k into this is going to be k. Okay, so then 16k into minus 16k is going to be negative 1. Then this side is going to, what's common is negative 16. Negative 16k, negative 16 into negative 16k is going to be k. Then negative 16 into positive 16 is going to be minus 1. Okay, as a result, you're going to have 0 is equals to 16k. You get what is outside, minus 16. Okay, and then you get what is inside here, which is just 1. Okay, and you get your k minus 1. Okay, so now when you reach this part, you're going to just say 16k minus 16, okay, is equals to 0 comma, you get the other one, which is k minus 1 is equals to 0. Then you divide by 16. You also divide by 16. Oh, sorry for that. I thought I've already done the transferring. Okay, sorry. So here it's going to be 16k is equals to 16. Okay, then you have your k minus 1 is equals to, oh, you also take this one this side. So it's going to be 0 plus 1. Okay, then you divide by 16, you divide by 16, k is equals to 1, comma, k is equals to 1. As a result, your k is just positive what? Positive 1. Okay, are we together?
Yes, sir.
Okay, so that's how you solve this question. Uh, it's a direct question. Okay, now you go to another question. Uh, So this question is saying that solve the equation. So these are those equations, when they bring them, make sure that you don't get it wrong, because it's 3 marks. Okay, it's like a free marks for you. Okay, you used to do this in high school. Okay, so that's why I'm saying it's free. But I know others, maybe they might not be able to solve it. But make sure that you get. I'm going to explain it. You understand it, and make sure that you get it correct when you write your tests. So this one, you have 1 over x plus 1 is equals to 1 minus 5 over 2x minus 4. So you're going to say 1 over x plus 1 is equals to, so here you have to also first start with what is it. So this is 1. So I'm going to write 1 over 1 minus 5 over 2x minus 4. So don't start by cross multiplying when you're here, because you might get it wrong. Make sure that you simplify the side. Even this side, it's all simplified, then you can cross multiply. Okay, or you can take everything one side, then you have equals to 0. But to avoid all those long processes, let's just do this. So this side we have 1. So here our common denominator is going to be 2x minus 4. Okay, so 1 into 2x minus 4, it is 2x minus 4. 2x minus 4 times 1, it is going to be, so just do this. I'm going to have 1 over, this one is already simplified, is equals to, so here I have my common denominator, which is 2x minus 4. Then 1 into 2x minus 4 is 2x minus 4. 2x minus 4 times 1, it's going to be 2x minus 4. Then 1 or 2x minus 5 into this is going to be 1. 1 times 5 is going to be minus 5. Okay, as a result, you're going to have 1 over x plus 1 is equals to 2x minus 9 over 2x minus 4. Okay, when you reach here, you cross multiply, you're going to have 2x minus 4 is equals to x plus 1, 2x minus 9. Then this is going to be 2x minus 4 is equals to x is multiplying with everything here. So you say x, then you say 2x minus 9. Then you get the 1, it's going to be plus 1. Then you say 2x minus 9. Okay, then you're going to have 2x minus 4 is equals to x times 2x is going to be 2x squared. X times negative 9 is going to be minus 9x. Then positive 1 times 2x is going to be plus 2x. Then 1 times negative 9 is going to be negative 9. As a result, you're going to have 2x minus 4 is equals to 2x squared, and then this will be minus 7x, because 9x minus or plus 2x is going to be negative 9x plus 2x going to be negative 7x, then minus 9. Then this is going to, I'll take everything this side, so I'm going to have 0 is equals to, so this was positive, when it goes this side going to be negative, so I'm going to have 2x squared minus the 7x. Then this is 2x, it's positive, comes this side is going to be negative 2x. Okay, then after that, well, this is negative 4 and goes the other side, it's going to be, so I'll write minus 9, which is already there. Then negative 4 comes this side, is going to be plus 4. Then I'm going to have 0 is equals to, this is going to be 2x squared. Then this will be minus 9x. Then this will be minus 5. Okay, so I also find the product. The product for this one is 2 times negative 5, that will be negative 10. And the sum is equals to negative 9. And the factors are, so the factors, you get two numbers when you put them there, when you add them, you get negative 9. When you multiply them, you get negative 10. And those two numbers are just negative 10 and 1. Okay, so in this case, this is going to be 0 is equals to 2x squared, and then it's going to be minus 10x plus x, because I'll replace these variables on the sum. Then I'm going to have this, then minus 5, like this. So this is going to be 0 is equals to, what's common here, it's 2x. Then 2x into x squared is going to be x. 2x into 10, negative 10x is going to be negative 5. Then what's common here is plus 1. Then 1 into x is going to be x. Okay, then 1 into negative 5 to be minus 5. Okay, so I'm going to have 0 is equals to 2x, okay, plus 1, what is outside, and I'll get 1, what is inside, x minus 5. As a result, 2x plus 1 is equals to 0 comma x minus 5 is equals to 0. Okay, as a result, my 2x plus 1, which is equals to 0, and my x minus 5 equals to 0 are what I'm going to have. As a result, this is going to be 2x. The 1 comes this side, is going to be equals to negative 1. Then this one is going to be x is equals to 5. Then this one is going to be dividing by 2 by 2. Then x is going to be negative 1 over 2, and x is going to be equals to 5. And there you get your two solutions. Are we together? Are we together, everyone? Okay, wonderful. All right, let's continue. We have a series of questions. So now we go to polynomials. Okay, so in polynomials, we have been told that let p of x be equals to x to the power 4 minus 2x to the power 3 plus 2x to the power 2 minus 2x plus 2. Okay, so this is a polynomial function. Then they're telling us to express p of x in the form of p of x is equals to x squared plus 1, okay, q of x, which is the quotient, then plus r, which is r of x, which is just the remainder. So this is the divisor, the quotient, and the what? So let me just label them. So this is the divisor, the number that is dividing the polynomial. Then this one is the quotient, the number that comes out after dividing. Then this one is the remainder, the number that remains after dividing. Okay, so now they're saying that where q of x is the quotient, r of x is a remainder, and p of x is being divided by x squared plus 1. Okay, so now after we have noted all those things, so here let us use long division. Okay, I encourage you to know all the methods, know them. Okay, know all the methods because they will be helpful in different circumstances. Okay, very, very helpful. So now, when you have this one, we have chosen to use long division. So we have the divisor, which is x squared plus 1. Then we have the polynomial function, which is this one. Okay, so what I'm going to do is that I'm going to say the divisor is x squared plus 1. Okay, this okay, so this number is dividing into this other. So this is just one number, so that's what I'm saying number, but these are expressions. Okay, algebraic expressions. So plus 2x. So this one is a very good one because everything is arranged in order. Minus 2x plus 2. Okay, so here so we'll use bring down. Okay, we'll be bringing down the what? uh this is grade 5. Okay, it's interesting that we are solving what we used to do in grade 5 and we're doing it now here. So now this one is x squared, okay, into x to the power 4. So this is going to be x squared. So what I do, or what we need to do, okay, we are supposed to only focus on this variable here, okay, when we are dividing. So I'll start with the first one. So when I divide with the first one, then what I'll get, I'll multiply with everything that is here. So I'll say x squared divided into x to the power 4, that will give us x squared. Okay, so now what I have gotten as my x squared, I'll multiply it with this. So x squared times x squared, that will be x to the power 4. Then x squared times uh, times 1, that will give us x squared. So I'll write the positive x squared here. You understand why I've written it there. So the reason why I've written it here, because here this one has power 3. So here meaning that in the we're supposed to get x to the power 4 plus x squared. But since we don't have the middle number, because here we have 3, okay? So I've just written it straight with this one so that I can easily subtract it. So meaning that here I don't have the one with x to the power 3, meaning that I have plus 0x to the power 3. Then here I'll just say plus 0x plus 0 so that I can easily subtract. So when I do this, I'm going to say minus, then what will start happening is that this one will start subtracting this one. So it's going to be x squared minus so x squared, or x to the power 4 minus x to the power 4, that will be 0. Okay, then it will be 0, uh, negative 2x to the power 3 minus 0x to the power 3 to just be negative 2x to the power 3. Then positive 2x squared minus x squared, that will just give us plus x squared. Okay, then negative 2x minus 0x is going to be minus 2x. Then negative 2 2 minus 0, it will be just be plus 2. So now the 0 number which is in front, I'll just rub it. Okay, so when I rub it, I have a new polynomial function which I'll divide with this divisor. Okay, that's what I'll be doing every time. Okay, so now I'll say x to the power 2 into negative 2x to the power 3, meaning that I'm going to have negative 2x. Okay, so are we together up to this point?
Yes, sir.
Okay, so after we write negative 2x, the negative 2x is going to multiply with everything that is here. When we multiply with everything that is here, we're going to have 2 times x squared. That will give us negative 2x to the power 3. Then negative 2x times 1, that will give us minus so I won't write it here because this one is going to give me 2x. Okay, it's what I'm supposed to get. It's supposed to be negative 2x to the power 3, then minus 2x. That's what I'm supposed to get, but I'm not I want to subtract easily, so that's why I'm writing plus 0x squared. Then I'll write now this component which is straight in line with this one, minus 2x. Then I'll say plus 0 so that I can easily subtract. So as a result, now I'm going to subtract negative 2x to the power 3 minus negative 2x. It is 0 because the negative and this negative are going to multiply, become positive. Negative 2x to the power 3 plus 2x plus 3, or 2x to the power 3, meaning that it will be 0 now. Then x squared minus 0x squared, that will just be plus x squared. Then negative 2x minus 2x, okay, minus 2x, or minus negative 2x, it is going to be plus 0. Then and then this one is going to be plus 2. Okay, so I'll rub the 0. Okay, okay, so after I've rubbed the 0, I have remained with this. Okay, so now here what I do, I'll do the same thing. So x squared into x squared, that will just be plus what? Plus 1. So the 1 is going to multiply with everything here, meaning that I'm going to have x squared. Okay, so here let me remove even this 0 which is here, so that I can have, I don't add other zeros there. So it's going to be plus 2. Okay, so that when I multiply with everything, I'm going to have x squared, then plus 1. Okay, then I'll subtract. As a result, I'm going to have so what will happen is that this x squared minus x squared, it is 0. Then 2 minus 1. Okay, so 2 minus 1, it is going to be equals to plus 1. So meaning that here we have 1. So meaning that 1 is our remainder. Okay, and then what we have gotten here is the sorry, the quotient. Okay, so this is the quotient, and then this is the divisor. Okay, so meaning that if you're expressing this expression in this form, meaning that I'm going to write p of x is equals to this is going to be x squared plus 1 because that is a divisor. So x squared plus 1, okay, our divisor. Then now our q of x, we've gotten it to be the quotient which is here, q of x. So what will happen is that I'll just write, so this is, let me do this. Okay, so that's the quotient. So now here I have the quotient which is what? Which is x squared minus 2x plus 1. So it is x squared minus 2x plus 1. Okay, then I'm going to say plus the remainder. Okay, so it's going to be the remainder we got was 1. So that will be your polynomial. Are we together? Are we together, everyone? Okay, so that is what you'll be doing when you're solving these questions. So now let's move to another question. So in this case, again, we have another question. It's on polynomial as well. Okay, so it might be a lot of work, but make sure that you familiarize yourself and you'll be able to solve all these questions. So now you have f of x. So this is going to be f of x is equals to x to the power 3 minus 3x squared plus 4. So you can even tell from here, meaning that you're going to have a lot of papers that when you'll be solving your test one, you have a lot of it because they'll tell you that you need to have a minimum of 15 pages at least, or 15 plain papers. So make sure that you solve, okay, solve very much so that you get good grades. Okay, so now we have f of x here, which is f of x is equals to x to the power 3 minus 3x squared plus 4. Okay, so now they want us to find I, which is just saying that they want us to find f of x when it is equals to 0. So this is just finding the equation. So meaning that we have x to the power 3 minus 3x squared plus 4 is equals to 0. So that is what we have as our what? As our polynomial function. Okay, so that is our polynomial function. Now what do we do? So here you need to solve this equation. Okay, you need to solve this equation very, very much. So now you can use synthetic division. Okay, you can use synthetic division, you can use long division, but the first thing you're supposed to do is finding a factor. Okay, so when finding a factor, you use the method of try and error. You try and error. So most of the times the numbers are usually plus or minus 1, plus or minus 2, plus or minus 3, because they'll give you a question like that. So probably they don't want you to be looking for very big numbers. Okay, so this is a clue which you need to have in your test. So you test these numbers. So if I'm looking for a factor, when I replace that number there, I must get a 0. Okay, so when I test positive 1, when I get 1, I replace on x 1 to the power 1 to the power 3 minus 3 1 squared plus 4 is equals to 0. So this will be 1 to the power 3, which is 1. Then this is going to be minus 3. And then this will be plus 4 equals to 0, meaning that this one is not a factor because this is going to give us what? A remainder. This is going to give us negative 3.
-1 work.
Negative 1 will work. Okay. All right. Wonderful. So when you try negative 1, so this is very interesting. So negative 1, so negative 1 to the power 3 minus 3, negative 1 squared plus 4 is equals to 0. This is going to be negative 1. And then this is going to be minus 3 plus 4. Okay, yeah, so we have our factor, negative 1. So negative 1 is our factor in this case. So what you do with your factor, you don't get it as negative 1, you get it as an equation. So when x is equals to negative 1, that is when it is giving us what? That is when it is giving us the expression. Okay, that's when it's giving us 0. So meaning that if it's the equation, the one who comes this side is going to be x plus 1. So x plus 1 is a what? Is a factor. So that's what you're going to do. Then when you do that, you say, so you can use long division or synthetic division. But in this case, let us use synthetic division. So since I've already shown you how to use long division, now let me show you how to use synthetic division. Okay. Yes.
Is it possible when you're trying this trial and error, you find, since we find the factor negative, is it possible to also find like another factor that to give us zero? Like,
Yes, it's possible. If meaning that you are solving it without without doing all this synthetic division, and meaning that you are just solving it with your trial and error. Clear? Okay. So now we found our factor, which is negative 1. So what we're going to do here is that since we're using synthetic division, so this is what we do in synthetic division. You're going to draw this. So when you draw this, you've seen this equation, okay? This equation, you're going to get the coefficients of it, okay? You just get the coefficients of it. So meaning that here there is 1, okay? That's the first coefficient, the highest degree, okay? Then followed by the next degree, which is what? Negative 3. So now this is a secret about synthetic division. Don't go, for example, you have x to the power 2 here, then you just go to this one has x to the power 0. It's just invisible, okay? Because any number raised to the power 0 is what? Is 1. Then you've skipped x to the power 1, okay? When you skip x to the power 1, you're going to do what? You're going to get it wrong. So what you do here, you write 0, okay? Then you write 4. Are we together? Okay,
Sir, may you kindly repeat?
okay. So you know that this is just the same as writing it as x to the power 3 minus 3x to the power 2. But since we don't know, we don't know what uh, the next one is supposed to be x to the power 1. So it will be x 0x to the power 1, just that it is not there because it is 0, okay? So the coefficient of it is 0. That's why it's just not shown there. So it's going to be plus 4, isn't it?
Yes, sir.
So meaning that I'm getting the coefficient. So I have 1, I have negative 3, I have 0, and I have 4. It has to be in order for it to work. So if you're having maybe some doubts, so just use long division, because you don't have to do this in long division. Okay. So that is it. So here we have 1, negative 3, 0, 4. So it's going to be our factor is negative 1. Okay, so we are going to drop the 1 which is here, it will come down. Then I'll say 1 times negative 1, it will be negative 1. I'll write it on the second one. Then I'm going to add negative 3 plus 1, negative 1, which will give me what? Which will give me negative 4. Then negative 4 will multiply with negative 1, okay? And then it is going to give me positive 4. Then 0 plus 4, it will give me a 4. Then 4 times negative 1, it will give me negative 4. Then 4 plus -4, it will be a 0. Okay, meaning that it is a factor. You've seen, right? Are we able to see that? We have no
Yes,
remainder.
sir.
Yes. So we have no remainder now. Let us express this as equation, what we've gotten. These are coefficients. Okay. So now the highest degree here was x to the power 3. So meaning that when you have these numbers here, these ones, they will come after. So they will come now when you have now a lower degree. Okay. Degree by 1 from this one. Okay, so it's going to be x to the power 2. So meaning that it is 1x to the power 2. So because you just follow the same order which is here. So there's 1, meaning that the first one is x, is 1x squared. Then this is going to, because here it was 1, it was x to the power 3, meaning that this was going to be 1x squared, negative 4x, and positive 4 as a constant. So meaning that we have our factor is x plus 1, so it's going to be x plus 1. Then the new equation which we're going to have is going to be 1x squared, which is just x squared, minus 4x plus 4. Okay, is equals to what? To 0. Are we together?
Yes, sir.
Okay, so after that, you're going to have x plus 1. Then you have x squared minus 4x plus 4 is equals to 0. Then this just tells us that here you're supposed to factorize this. So it's going to be x plus 1. And then here, what's the product? The product is positive 4. The sum is negative 4. Then the factors are just, so I'll just find them for you. So looking at the way it is here, it's just negative 2 and negative 2. Okay, as a result, it will be equals to x squared minus 2x minus 2x plus 4 is equals to 0. As a result, x plus 1, then x squared, okay? So this is going to be x, which is common, then x minus 2. Then what is common here is negative 2, then x minus 2 again, so it's going to be equals to 0. As a result, this is going to be x plus 1. Then you get what is outside here, which is going to be x minus 2. Again, what is inside, you just get 1, which is x minus 2 is equals to 0. As a result, x plus 1 is equals to 0, comma, x minus 2 is equals to 0, comma, x minus 2 uh, is equals to 0. Then this is going to be x is equals to negative 1, x is equals to 2, and x is equals to 2. Okay, are we together?
Yes.
Okay, so now you've solved the first one. So that's what they just wanted you to do on the first one. Then the second one, they're telling us to sketch. Okay, they want us to sketch uh, the graph. So this graph which we have here, it's a polynomial, meaning it has x to the power 3. Okay, so when you're sketching, they don't want to start solving about the turning point, so they just want you to name the points which are there. Okay, so that's what they just want you to do. Okay, so when you're sketching this one, uh, we've already found intercepts, because mind you, these are just intercepts. So this is negative 1 comma 0, and then also we have 2 comma 0. Okay, and then this is again 2 comma 0. So this point again looks like it's touching it again after it moves. So in your sketching, so you already have your so most of the times we just say x is equals to 2, just 1, because these are just 10 points. Okay, so these are intercepts, and mind you, these are x intercepts. So the only thing you're supposed to find is the y-intercept. So a y-intercept is when x is equals to what? To 0. So this is f of x is equals to x to the power 3, and then it was minus 3x squared, then plus 4. Okay, so they don't want you to start solving so many things. So now when x goes to 0, so it's f of 0 is equals to 0 to the power 3 minus 3 to the 0 to the power 2, and then plus 4, meaning that it will be equals to 4. Okay, f of 0 is equals to 4. Then what you're going to realize here is that this is just a coordinate which is 0 comma 4. Okay, it's a y-intercept. So after having this y-intercept, you just plot Cartesian plane. Okay, so you have points, you have -1, you have 2. Okay, then you have a turning point at 0 comma what, 0 comma 4, meaning a 4 is here. Oh, not turning point, an intercept. So 4. So now you just start, because here again we're seeing that the graph is touching this part 2 times. Okay, so that's why we got those solutions. So here you have a coordinate, even here you have a coordinate, even here you have a coordinate, and then you just test for one. So we start testing. Okay, we'll be testing. For example, when I put 1 in the equation, what am I getting? When I put 1, so when I say 1 here, so I want to see what 1 is. So when I put 1, in this case, it's going to be 2. Okay, so it's going to be 2. So meaning that here it's going down. Okay, it's going down, to be going down. Then when I put 1.5, that will give me, okay, to be so complicated there, to be something like 225, 2.25 minus, oh, okay, as we've seen how it's moving, so already it's like this. Okay, it's turning somewhere here. Then it is going like this. Okay, so we are able to see all this. Okay, so that is how you sketch it. You don't, there's no need of showing like a point. Okay, like to say this one is a turning point. No, there's no need. So I'm sure it is turning somewhere here like this, but it's not touching this line, because here when you start touching this line, it has to go back. Okay, on 2 there's a point which is repeating. Okay, so it's only touching the graph at what, at -1 comma 0 and 2 comma 0. Okay, are we together? Are we together, everyone? Okay, I'll send this one. I'll send it as to show you the image how it is. Okay,
So I have a question.
yes.
So now my question is, how did you manage? I didn't see where you were doing the testing for like how to find the turning point, because the one we have there, our four, that's the y-intercept.
Yes.
So where is it coming from?
It's a point. I'm seeing the way the graph is moving. Okay, so it's like this. uh there is no need for you to find the turning point. You just turn it anywhere. Okay, that is what I can tell you. You turn it anywhere. That's what you're going to do. So for this question, okay, it has 2 points like which are the same. Okay, but for example, if we had something like a 4 here, meaning that here it would have been something like before here, right? So meaning that it would have gone and also touched here, but I'm not minding about this point. Okay, uh it would have meant that it would be go like this if I had a 4. So here this is what is just telling me that I can turn it because I've not learned calculus. In calculus, that's when you start turning them, like finding the turning point. Okay, but since you've not learned calculus, it's just better off you just like sketch it like that. Okay, you just turn it anywhere. So I've not
Okay, it's understood.
yes, I've not calculated for it. I've just turned the graph anywhere. Okay, because I've not learned calculus. Okay, no, not that I'm not learned. I'm saying that you've not learned calculus in short. So let us move forward. Okay, let us solve the other one. Okay, are we on the same page?
Yes, sir.
Okay, so we're going to solve so many questions about that. We have so many examples, and we are going to understand it better. So now we have another question here. Say it's a polynomial as well. This one is saying that the polynomial p of x is equals to ax to the power 3 minus x to the power 2 plus bx minus 1. It leaves remainders of 1 and negative 34 when divided by the x plus 2 and x minus 3 respectively. Find the values of a and b. Okay, so you've seen this one is the remainder theorem. Okay, the remainder theorem says that if you have uh, a divisor, then this divisor is leaving a remainder. Okay, when you replace that value of x, for example, this is x plus 2 is equals to 0, meaning that is x is equals to negative 2. When I plug in this negative 2, I plug it into this function. I must get the remainder, which is the first one. So they said respective, meaning that this one is for this one, and this one is for this one. Okay, so from this information that I have, I'm going to say that uh, when when it is x plus 2, right? Meaning that I'm going to have uh, or negative 2 when x is equals to negative 2. Okay, so meaning that I've gotten the first one.
Sir, kindly repeat.
Oh, okay. So the remainder theorem, it states that when you have a function, okay, and it is being divided by a factor, okay, so in this case, this factor leaves a remainder, and this factor which leaves a remainder is x plus 2. So you find just the value of x, which is just x is equals to what? To negative 2. Now, when you plug in this negative 2, like p of negative 2 is equals to uh, a, then you plug in on x negative 2 like this, minus negative 2 squared plus b, then there is negative 2 minus 1. It must give me what? It must give me a 1. Clear?
Yes, thank you.
Yes. So meaning that here, that's what I would do here. So meaning that p of negative 2 is equals to, I have my a, and then I'm going to replace with negative 2 because I'm getting this one. So this one, x plus 2 is for the first one, negative 34 is for the second one because they've said respectively. So in this case, I'm going to have negative 2 here to the power 3 minus negative 2 to the power 2 plus b negative 2 minus 1. Then this is going to be, so this one is 1. Okay, I must get 1. So it is equals to, this is going to be negative 8a. Then this one is going to be minus 4 because negative 2 squared is 4. Then times negative, it will be negative 4. Then this is going to be minus 2b. Then this is going to be minus 1. Okay, so as a result, because I'm seeing something like so I'll just say I'll take these ones this side, even this one this side, so that I have 1 plus 4 plus 1 is equals to negative 8a minus 2b. Okay, as a result, I'm going to have 6 is equals to negative 8a minus 2b, and this becomes my equation 1. Okay, now let me go when it is x minus 3 or x is equals to 3. So in this case, when I plug in, when I say that p of 3, it is supposed to be equals to a multiplying with the 3 to the power 3, then minus the 3 squared plus b, uh, which is 3, then minus 1. Okay, then I know that p of 3 is supposed to give me negative 34. It is equals to 3 to the power 3, it is just 27a. Then this is going to be uh, minus 9. Then it's going to be plus 3b minus 1. Then this is going to be negative. So I'll take those ones like negative 9 and negative 1 this side, meaning I'll have negative 34. Negative 34 minus or plus 9 and plus 1 is equals to 27a plus 3b, and this becomes my equation 2. Okay. Oh, before I do that, so it's going to be negative 34 plus 9, that is just 25, or negative 25 plus 1 to be negative 24. Okay, is equals to 27a plus 3b, and this becomes my equation 2. Okay, are we together?
Yes.
Okay, so in this case, I'm going to have negative 8a minus 2b is equals to 6, and then I have another one which is 27a plus 3b is equals to negative 24. Okay, so now here I have a simultaneous equation. So solving simultaneously, using elimination method, what I'm going to do, I'll multiply the one at the bottom with a 2, this one with a 3. Okay, so 3 times 6, that is 18. 2 times negative 24, that will be negative 48. And then this is equals to like this. So 3 times this one is going to be negative 6b, and then 2 times this is going to be plus 6b. Then 3 times negative 8, which is just going to be negative 24a, and then 2 times 27a, it is going to give us 54a. Okay, as a result, this will give us 0 for b, and then after that we're going to have this is going to be 0, then negative 24a plus 54a, it is going to give us 30a. Okay, then it is equals to 18 uh, positive 18 minus plus negative 48 is going to give us negative 30. So you divide by the 30, even this side by the 30. As a result, your a is going to be equals to negative 1. Then now getting one of these equations, which is negative 8a. So taking I like doing this. So taking equation I, and just so it is negative 8a minus 2b is equals to 6. Then replacing it with the a, since a you've calculated, so it's going to be negative 8. negative 1 minus 2b is equals to 6. Then as a result, this is going to be positive 8 minus 2b is equals to 6. Then the 8 comes this side, is going to be negative 2b is equals to 6 minus 8. As a result, negative 2b is going to be equals to negative 2 divide by negative 2 divide by negative 2. As a result, your b is going to be equals to 1. Therefore, a is equals to negative 1 and b is equals to 1. Are we together? Okay, I'm sure people are tired. Uh, uh, we continue. We only remain with one question. We only have about, I think we have one question remaining and we'll be done. But people are tired, they're even leaving the class. Okay, we solve the question.
Yes, sir. Let's proceed.
Okay, so let's solve it, then we call it a day. So now, the last question for this one, it says that given that 2x to the power 3 minus x to the power 2 minus 7x minus 5 is equals to ax plus b, open bracket, ax, x minus 1, x plus 2, then plus c. Okay, so they want us to calculate for all the values of x, find the values of a, b, and uh, A, B, and C. Okay, that is what they want us to do, what to find. So in this case, what I would encourage everyone to do it is to expand this. Okay, so we have 2x to the power 3 minus x to the power 2 minus 7x minus 5, okay, is equals to ax plus b, x minus 1, x plus 2 plus c. Okay, so my goal here it is to expand this. Okay, so I'm going to have ax plus b multiplying with x minus 1, x plus 2 plus c. Okay, so therefore I'll start with I can start with 2, so I can start with ax and this one, so meaning that I'm going to have I'll say I'll start with these two. Okay, so that I,
Sir,
yes,
it's actually ax plus b, open brace x minus 1, open brace again x plus x minus 2, not plus 2.
it's plus here.
It's plus It's 2. Plus 10. Oh, I can't see. Alright, thank you.
All right, it's positive. Yes. All right. Thank you. So here, we're going to expand. I'll start with this one so that I ease the work. So I'll say ax times x, it will be ax squared. Okay. Then ax times negative 1, it will be minus ax. So I've multiplied ax with everything here. So I'm just doing this because I don't want to take much space. So now I'll get the b. B times x, it is plus bx. Then b times negative 1, it will be minus b. Okay, so we've expanded this one. Then we have x plus 2 here plus c. So now again, let us start expanding this one as well. So this one we're going to have x is going to multiply with everything here, and the 2 is going to multiply with everything here. Then us getting this one multiplying with everything, that is it. That is too much. So let us get the smaller one, then multiplying with everything. So it is x times this one here is going to be a x to the power 3. Then x times ax, it will be ax squared. Then x times bx is going to be plus bx squared. Then x times the b is going to be minus bx. Okay, we are done with the x. So now let's go to 2. So 2 times ax squared is going to be plus 2ax squared. Then 2 times ax, negative ax is going to be minus 2ax. Then 2 times bx is going to be plus 2bx. Then 2 times negative b, it is going to be negative 2b plus c. Okay, are we together?
Yes.
Okay, so now here we have some variables that can subtract. For example, which one? Bx. Okay, bx can subtract. Okay, even here, even ax squared, they can subtract. So I'm going to have ax to the power 3, then ax squared, negative ax squared plus 2ax squared, which is going to be plus ax squared. Then so bx doesn't is not, so I'll say plus bx squared. Then what is going to happen is that here I'm going to have so bx, negative bx plus 2bx going to be plus bx. Then what is going to happen is that I will have yes, so minus 2b plus c. Okay, so now remember that this one was equated to 2x to the power 3 minus x to the power 2 minus 7x minus 5. Okay, so I bring back this. So now what I'm going to do is that I'll equate the one with power 3, I'll equate it to each other. Okay, that is what I'm going to do. So meaning that in this case, we have ax to the power 3 is equals to 2x to the power 3. Then here you can cancel the x to the power 3. As a result, your a is equals to what? To 2. Are we together?
Yes.
Okay. Then here you have ax squared. So we're going to say ax squared plus bx squared. So you are going to add equate it to what? To the one with which is negative x squared. Okay, like that. So when you do that, it is going to be, so this is, you already have your a. Okay, so don't forget about that. You already have your a. So a is 2. So you replace here with 2x squared plus bx squared is equals to negative x squared. Then what will happen is that this one will go the other side. It's going to be bx squared is equals to negative x squared, okay, minus 2x squared. As a result, it is going to be bx squared minus, or is equals to negative x, or negative 3x squared, isn't it? So as a result, that will give us the x, and the x will go, b will be equals to negative 3. Then now you have another component here, which is negative 2. Yes. So okay, let me just check. Okay, this is bx. And then now you go to for another component, which is the constant, because you found for A and B and so let's find for C. Okay, so
Sir, can you kindly repeat on that part where you said ax squared plus bx squared is equal to negative x? I don't understand where the 2x squared came from.
we found A to be 2, so we replaced,
Oh,
yes. Okay, so we are going to have that. So we have B to be this, then we have a constant. Okay, so we include all the constant values, which is this one and C. Okay, which are going to say that negative 2b plus C. uh, so in this case, uh, plus C is equals to what? Is equals to negative 5. Okay, the constants. So it's going to be negative 5. Then your B is negative 3, so it's going to be negative 2. Then B, which is negative 3, and plus C uh, is equals to negative 5. Okay, then this is going to be negative 6. Oh, positive 6 plus C is equals to negative 5. Then comes this side, your C will be equals to negative 5 plus negative 5 minus minus 6. As a result, C will be equals to negative 11. Okay, so therefore our A is equals to 2, our B is equals to negative 3, and our C is equals to negative 11. Okay, are we together?